In the Swedish town of Eksjö, homes are manufactured from Scandinavian trees, including for the German market. Around 500 Swedish prefab houses are built in this factory every year. However, technical problems jeopardize the schedule.
It's not good when it stops like this. This means overtime.
The shell of the house needs to be set up in Germany in just 4 days. There is no room for delays.
Full of water. All this will definitely have to be replaced entirely.
Småland, in southern Sweden. Trees are felled all year round in the highlands forests. Every single tree trunk felled here serves as raw material for a typical Swedish house. These classic wooden houses are growing in popularity in Germany too. Their characteristics: the timber frame design, cozy verandas, and in most cases, dark red wooden cladding. We will follow this house from its manufacture in Eksjö till its assembly in Germany. The Mellangården style is in keeping with classic Bullerby style. It boasts 176 square meters of living space and costs around 350,000 euros, including installation. Our story begins in the Paslemullen forest. Under the supervision of Ulf Hildein, 500 trees are felled here daily for the production of wooden houses.
We fell around 60% spruce and 40% pine here. We need 120,000 cubic meters of wood to keep our production going all year round.
At least 4 of these 450 horsepower harvesters are in operation on a daily basis. These machines, worth around 500,000 euros apiece, harvest 300 cubic meters of wood daily. In less than a minute, a harvester such as this one fells the tree and saws it into pieces ranging from 3 meters 10 to 5 meters 50. The harvester fells up to 500 trees a day, clearing a space the size of a hectare in less than 8 hours. New trees are planted by the house manufacturer after the existing ones are felled. This is enshrined in Swedish law. The felled trees are around 100 years old and stood up to 50 meters tall.
You can tell how old a tree is and how well it's grown by the number of concentric rings in the wood. This wood is well suited for construction timber and for panels used for building the timber framing for our houses.
Trees that have grown slowly have a particularly good wood density, which gives you the stability you need for building houses. Structural timber is made from these trees, and they serve a supporting function later on. The tree trunks travel from the forest to the factory in Eksjö, 13 kilometers away. At least 4 trucks carrying 40 tons each travel along this route each day. These vehicles have an excess length of 24 meters. They would be illegal to drive in Germany. 10,000 cubic meters of tree trunks are stored on the courtyard adjacent to the lumber mill. Mill owner Anders Magnusson takes care of quality control from the moment the timber arrives.
The wood is already sorted by dimension and quality. Then it goes into the factory where it's made into construction material and panels. You want good quality wood without any knots or surprises for this kind of work.
Before they can proceed further at the sawmill, an enormous sorting machine moves the tree trunks into the correct position.
The tree trunks are turned around here so that the thicker end faces us, and the narrower part faces away from us. We sit here and sort and turn the trunks before they are sawn.
The trees are fed into the debarking unit, with the thinner end going first. It strips the bark off the tree trunks. The machine works very precisely. The wood beneath the bark is not damaged. It takes less than 10 seconds to completely debark one tree trunk. The bark that has been stripped off is sold later as bark mulch. A laser measures the diameter of every single trunk before it is sawn. This way, the computer can calculate the perfect cut. A cut that minimizes waste. The result is structural timber, such as planks, boards, beams, and battens, with enough rigidity for building houses. At present, the construction timber contains between 20% and 30% wood moisture. This is still too high to be used in construction, so it's put into a giant kiln. They lose moisture inside this electrically heated wood drying machine. Foreman Andreas Kielberg monitors the drying process regularly.
The wood is laid out to dry for about 5 days at 75 degrees Celsius.
The worker sticks these two metal rods into the wood to measure its moisture content. The device measures electrical resistance. The smaller the resistance, the more water there is in the wood.
We're measuring the moisture content to see whether the wood is dry enough. The moisture content should be 18% maximum.
The device reads 15%, which is ideal for building. The wood can shrink and break during the drying process. If this happens, then it's useless as construction timber. The wood is put into interim storage to protect it from the rain. Before it's used, all the construction timber is checked thoroughly for cracks one more time.
I'm checking to see whether the wood is flawless and fresh and that there isn't any curvature in the battens. The wood has to be completely flawless, otherwise it would no longer be suitable for building.
The inspected wood gets a final cut using a high-performance carpenter's plane. A milling machine cuts boards with tongue and groove, which will later be made into roof panels. The machine stops suddenly. A piece of wood has jammed. Delays like these are not well received by the factory's owner. But when sensors stop the machines, there's nothing he can do.
Precision is a very delicate subject here. If a batten is out by a few millimeters or centimeters when it goes into the machine, and a sensor picks it up, the machine will stop immediately. One of the employees then has to remove the batten as quickly as possible.
The employee is able to retrieve the jammed piece of wood with a pry bar. The machine is working again. Next door, a fully automated machine is staining panels to be used in the house's cladding. The combination of staining and varnishing serves to protect the wood against moisture and lasts up to 6 months. It's at this point that the final coat of paint has to be applied to cladding at the very latest. The wood dries for 4 minutes at about 60 degrees. Each day, the machine stains 24,000 linear meters of panel for the cladding of a typical Swedish house. The house that we're following to Germany will also get this classic exterior timber framing. Depending on its size, the Mellengården model is made from at least 300 building components, and will offer 176 square meters of space. This Swedish house is designed to be a family home, but the owner wants 2 units containing 12 rooms in total. In the factory's office, 5 engineers and 7 architects are working hard to make even the most unusual dream home a reality. Swedish customers, for example, have completely different tastes to their German counterparts.
I Sverige säljer vi mer moderna hus.
In Sweden, we tend to sell modern houses. Our German customers love the typical Swedish style, red houses with white window frames. And that's why these clients often turn to us, so they can get a real Swedish house.
And you can choose between so much more than just different types of cladding.
Färdighus är ju egentligen...
A prefab house is not actually a completed house that will be suited to all customers. Every prefab house is tailored to customers' individual tastes in Sweden too. If customers request something that is above and beyond our standard model, the house can become considerably more expensive.
This customer, for example, wants an unusually high number of rooms. More rooms than the standard model offers. This house will cost around 350,000 euros, including installation.
Jo, när jag har gjort färdigt min ritning här.
Once I've finalized my drawing, it goes on to the design office where the production drawings are created for the factory.
Som ritar produktionsritningar till fabriken.
There are approximately 200 employees in the entire factory. Almost 500 Swedish houses are built per year inside this 6,000 square meter large workshop, under the supervision of production manager Daniel Sparre.
Production functions in such a way that the operator sees the drawing, decides which wood parts they need, and then the sensor gets the part that matches the data exactly. The machine is pre-configured for cutting. Man and machine work hand in hand.
A worker cuts at different angles and lengths with the help of the computer and the plan. He will have completed all the construction timber for a whole house over the course of 1 working day. Bengt Ragnarsson and his colleagues fit around 100 windows into all wood frames every day at the window station. These will later be incorporated into the components for the exterior wall.
It's especially important further down the line that the window frame is watertight. We achieve this with a rubber seal.
In Germany, windows are often installed using foam rather than a rubber seal, and this can become porous over time. Swedish houses are, not least because of their window technology, particularly watertight and highly energy efficient. More and more German customers value this. That's why the expert knows straight away which windows to use in a house that's destined for the German market.
The windows we manufacture for the German market often have glazing bars like these. Some windows even have more bars than there are on this one. It gives them a certain charm.
The basis for the exterior wall components is built here at this station. One worker inserts the wood-cased windows into the wooden frames and then insulates the cavities with mineral wool. "30 windows are fitted into the walls. The Melon Garden house consists of 25 external components in total. "120 linear meters of wall are to be built here over the course of a day. But suddenly, everything has ground to a halt. Sales director Jari Zari is responsible for the German market. He tries to keep abreast of the build's progress. But now, things have ground to a complete halt.
What's going on here? Can you get it working again?
We're not sure what the cause is.
Will it take long before it's up and running again? Is there anyone here who can repair it?
We'll call someone. I'll get the phone.
The computer system has crashed. Jari Zari quickly tries to get someone from IT support on the phone.
It's not good when it grinds to a halt like this. We have to meet certain quotas of linear meters each day. So this means working overtime.
Overtime and financial loss. IT services have to provide support over the phone as quickly as possible.
Now that the experts on the phone have advised them what to do, what buttons they need to press, and so on, 20 minutes later, and it's all up and running again. The guys have got things under control again.
Finally, the software problem has been resolved. The machine is working again, and the wall component makes its way onto the next station. The workers treat the inside of the wall with a breathable foil, also known as a vapor barrier. Next come the counterbattens, which are secured with the help of a nail gun, and a second layer of insulation using mineral wool.
A wall structure is always made in such a way that the interior has a vapor barrier which prevents moisture from getting into the house. The exterior, however, is open so that the structure can breathe, while the barrier ensures that moisture does not get in.
The inside of the components for the exterior wall are sealed with OSB panels. The workers then turn the wall over. Now they have to consider several details that will become important when the components are transported to the construction site. This includes thinking about transportation loops.
Depending on how you insert it, you can see how many kilos it can bear. And this has to be done in a certain way, so that the crane can lift the wall component.
A timber structure has to be able to breathe. Otherwise, you'll quickly find a buildup of mildew and fungi. That's why the wind barrier that the workers are now mounting onto the exterior of the wall components is breathable. Counterbattens come after the draft shield, onto which the timber frame will be fixed further down the line.
The counterbattens are very important because the structure is open and able to breathe. But the wooden cladding also needs to be ventilated, and that's why we have this air gap behind the timber frame.
And that's how the exterior wall is built. Vapor barrier, insulation with mineral wool, draft shield, counterbattens, and then the exterior frame. The air gap between the counterbattens and the timber frame is extremely important here. This rear ventilation of the cladding prevents long-lasting moisture and hence the buildup of fungi and mildew. The workers also go to great lengths to protect the house against other unwanted roommates.
This here is what we call a mouse grate. And this stops mice from getting into this area, which has been rear ventilated, and on which the timber frame will be installed next.
The workers lay the panels for the typical Swedish wooden cladding in the tongue and groove method on the counterbattens. Metal rails hold them in the correct position.
We measure the upper edge for quality control purposes and correct anything that is offset. This is important because this edge, for example, might need to fit with another edge further down the line. And that's why the panel in front of the upper wall has to match the one in front of the lower wall.
A high-tech nail machine secures the panels. The device presses the nails into the wood with compressed air and 500 kilos per nail head. This machine, worth 500,000 euros, has a 0.1 millimeter precision factor. Within 4 minutes, 500 nails have been sunk into the wall component. The workers secure the windows and doors. The first exterior wall of the house is ready after 4.5 hours. Here too, Sales Director Jari Zari checks to see whether everything is running according to schedule.
So here we have the interior wall production for our German houses.
The interior walls are also constructed according to the timber frame construction method. 28 interior wall components will be needed for the house.
You can see some of the structure here. This is the insulation. On the other side, there are OSB boards. And then when it's on site, the team will install the electrical lines, the sewage pipes into the walls. And once that's done, it will be sealed with either Fermacell boards or plasterboard.
The Swedish house gets 9 exterior walls and 15 interior walls on the ground floor. Before the upper floor can be put in, the engineers lay ceiling cassettes on the walls. These cassettes form the ceiling for the ground floor unit and the floor for the upper floor. The ceiling has to be able to take 250 kilos of weight per square meter once it's built. Carpenter Samuel Johansson and his colleagues use an extremely stable wood.
This is the station where we build the ceiling cassettes for the Swedish houses. They're made out of Cato beams, which comprise several layers. You can see here why they're so special. These Cato beams are made from plywood boards that have been glued together, and that's why they are extremely stable. They're very straight and will not warp.
The insulation is made from mineral wool. On the exterior, it's 600 millimeters thick for thermal insulation. Between the floors, it's 450 millimeters for soundproofing. A chipboard panel then closes off the ceiling cassette. There are 11 ceiling panels for the house that will soon be delivered to Germany. Dainty gables and dormers make the Swedish house feel even more homey. Roof trusses are needed for this part. These are the load-bearing parts of the gables and dormers. A worker assembles every single truss by hand. The alignment is carried out using a modern laser, which ensures everything fits exactly to the millimeter.
I can see exactly whether the batten is in line with the wooden beams using the laser.
The carpenter joins the battens using nail plates. A machine compresses the panels with 35 metric tons of pressure. 100 of these roof trusses are built here in this way each day. Of course, some of them even get the same classic Swedish exterior timber frame that is used for the exterior walls. It's not just wooden cladding, but wooden houses in general are growing in popularity among Germans too. However, sales director Jari Zari often has to combat stereotypes.
When you hear things like wooden houses burn down quickly, wooden houses are dangerous, You ask yourself, why do we Swedes have a long tradition of making wooden houses? Do we want dangerous houses here in Sweden? Sure, it's not like that at all. We see our standard structure, this wall that we see here now with a fire resistance rating of F30B. And this means that it would take at least 30 minutes for the flames on the outside to reach the inside.
Many historical towns in Sweden have houses that are several hundred years old. They brave the adverse weather conditions, and in so doing prove one thing in particular: longevity. Swedish houses are largely made from renewable resources and are very energy efficient. This doesn't just go down well with the Swedes. The demand is also steadily rising among the Germans. Anders Lindholm is a third-generation manufacturer of Swedish houses. The owner of this factory, which makes prefab housing, remembers how it all began.
Vi har hållit på sedan 1961 och levererat hus till Tyskland.
The first Swedish house to go to Germany was in 1961.
Från början så var det nog så att
I think that those who wanted a Scandinavian house had links to Scandinavia or Sweden in the first place.
till Sverige exempelvis.
Maybe they had been here on summer vacation. Maybe they had immersed themselves in the world of Astrid Lindgren and saw these beautiful red and white houses that are typical for Sweden.
Knutar som är typiskt svenskt. Så den kopplingen fanns säkert.
Today marks another house's journey from Sweden to Germany. The finished building components for the 500 houses that leave the factory each year are stored on 8,000 square meters. Warehouse manager Jonas Dahlsten starts loading the house.
The trucks must be loaded in the right order. It's important everything that is delivered in the first truck is needed on site at the beginning of the build, and everything delivered last is what's needed at the end.
The workers load the building components onto the truck according to a sophisticated system and strict sequence. At least 300 building components are sent on this journey for every house being built. Four trucks travel a distance of 1,173 kilometers within 4 days, fully loaded with individual parts for a Swedish prefab house. The parts travel from Eksjö in Sweden's Småland to Telgte in Germany's Westphalian region. The preparations for installing the Swedish house have been underway here for weeks. The base plate, including integrated pipes, those used for underfloor heating among others, is ready to be built on. The connections for water, sewage, and electricity run through all of the low-energy base plate's layers. The plate is doubly insulated and has integrated underfloor heating. The plan is to erect the 176 square meter large shell of the house in less than 4 days. It consists of 300 building components. The customer has asked for 2 living units. This means the build will take considerably longer to complete. The builders still have to keep to their timings. The installation team from the German partner firm have decades of experience with Swedish houses. Nevertheless, a challenge awaits site manager Ebhard Krombach and his team with this build.
Sole plates are mounted onto the base plate. These are secured, as you can hear, using special dowels. Once done, the first wall can come off the truck and set onto the plates. We have a very compact living space here. We talked about there being many walls at the preparation stage, and this is why it will take a bit longer to finish.
The pieces of construction timber on the base plate are called indicative thresholds. The walls will soon be positioned onto them. This saves time.
The ground is level, so we don't need to straighten the walls. The threshold does that for us now. We put the walls on it and screw the walls to it. Further down the line, they will also be doweled, and that's why we put this threshold here. You can also set the walls without this threshold, but that will lead to more work. This here means less work.
The sole plates have been set. Then the crane, with a weight of 33 tons and a lifting force of 55 tons, lifts the first exterior wall out of the truck. The crane operator has to place the underside of the wall exactly on top of the sole plate, like a plug system. Precision work, with a wall component weighing 1,000 kilos.
It looks like it's stuck on something.
What?
It's stuck on something.
It's caught in the middle.
Stop. Is it completely level on your end?
It looks like it.
Does it rest flat on your end? Is it flat at your end?
Assembly Supervisor Detlef Buchwiese bolts the exterior wall temporarily to the sole plate. For more stability, he also fixes an iron bar to it until the component can be properly attached later on.
For the time being, we're fixing the exterior wall to the sole plate in just a few places. Later on, we'll tighten it further with a distance as required by the structural analysis. However, that will be done later when we have more time.
The longest component for the exterior wall is almost 8 meters in length. Lowering the elements into place between the already installed walls requires exact coordination between the crane operator and the construction team. The installation team spends a good 3 hours setting the exterior walls down. All exterior wall components are up. Assembly Supervisor Buchwiese and his employees line up the walls at right angles to each other with the help of a beam grip.
Let go a little bit. So, what's the spirit level doing? Yeah, and that one? Great, very good. Beam grip, or you can also call it a beam tensioner.
Panel tensioner.
A spring cramp, exactly. We can use them to align these walls exactly.
We have 2 walls that move, and we have to bring them into line at a right angle. And we can't do that with a vise, so we use this thing.
Now come the 15 interior wall components for the ground floor. For these, the workers mount wooden guide rails to the walls. They serve a similar function as the sole plates on the floor. In technical jargon, these are referred to as bars.
Because it's sealed on this side and the slot for the bar is on the other side, see? That means I'll wiggle it a bit to squeeze it in. Actually, I'll do it with a ladder. It's better to do this from above. We always have to keep an eye out so that wall and bar stay together.
There are numbers here, 53, 52. and we see the same numbers on the wood, meaning the walls. And that's how the person working on that part knows where everything goes.
The assembly supervisor saws holes in the exterior of the walls for pipes and cables that run along the base plate. Later on, these will be sealed with plasterboard. After an additional 4 hours, all 15 of the interior wall components have been installed on the ground floor. Three steel beams and a steel support are supposed to provide the house with additional stability. The beams are 300 kilograms apiece, 160 millimeters tall, and about 12 meters long.
Why have steel in a wooden house? It's a matter of structural integrity. There are certain parts where the walls are so far apart that wood is simply not enough. Steel has a higher resistance to bending, and that's why we use steel in this case.
Now, after the steel beams, the ceiling cassettes follow. They form the ceiling for the residential unit on the ground floor and the floor for the living space on the upper floor.
It has to come down straight from above. What follows next is the mounting of the ceiling components, piece by piece. That means that the first one is secured in a few places so that it doesn't move. Then each component is added on and the parts are glued and screwed together. Once that's done, it's all peachy. They'll be secured later on and screwed tight from below at various points.
The construction team now continues to install the 11 ceiling cassettes. After 10 hours, the end of their shift is still nowhere in sight. Carpenter Robert Cole is tasked with storing a wall component for the upper floor behind the house for later use. There isn't enough room in front of the house. What is challenging is that the crane operator cannot see the small space between the building site and the neighbor's fence from inside the crane.
And down. Arm down. And down. Slowly, stop. Okay. You could move another half meter. The wood needs to move further, okay? Okay. And down. From the crane, you can't see a thing. And we have a walkie-talkie, so he's putting his complete trust in us. So that means that if we don't explain things to him properly, we're going to have a problem. This is a question of trust between the crane operator and the guy whose job it is practically to move the components.
The first day of the build draws to a close. Site manager Ebhard Krombach takes another look around the site.
I'm always happy when I come here because I also do the planning of these pipelines myself and can see that everything is where it's supposed to be. That's definitely the case in here and in there too, of course. This is noteworthy, this ventilation shaft. It goes up through the wall and a ventilation grill goes on top. Here we have a really airtight house. We can also prove that it's as airtight as it needs to be, and that's why we need controlled ventilation. There are customers who say that they could simply open windows for ventilation, and my argument is that of course you can open your windows whenever you want. This isn't a house with windows that you aren't allowed to open, but if you do so, you let your energy escape from the house and run up your bills, while the controlled ventilation does this for you and keeps costs down.
The federal government subsidizes energy-efficient houses. Swedish houses score highly in this regard. This means that the owner of this house can receive aid or a low-interest loan from the state-owned Development Loan Corporation. The state of construction after the first day. The team has built indicative thresholds. External and internal walls have been erected on the ground floor, and ceiling cassettes have also been laid. The second day of the build has begun. It has rained overnight. Everything is wet. What does this mean for the construction team?
Unfortunately, it's been raining heavily. This is the weakest point if we were to install the cassettes right now. In theory, some water can run into the insulation underneath. We have to keep going. We can't just stop when it rains. That's just the way it is.
Site manager Eberhard Krombach checks inside to see how much damage the rain has caused.
Water in the ceiling from the rain. Full of water everywhere. Extremely wet. All this will definitely have to be replaced entirely. If an area is unaffected by the water, we don't need to replace anything. But of course, we're inspecting every single area. The wall will be replaced during the completion of the ground floor interior. Too bad, but we can't help it.
Outside, the team is getting the floor transitions ready for the upper floor. A breathable vapor barrier is also put to use here to protect against moisture. The insulation is also made from mineral wool. The lateral external walls are the only walls that are not built on top of the sole plate, but directly on the walls of the ground floor for structural reasons.
And down. Stop.
The 8 exterior walls for the upper floor have been set within 4 hours. There's a difference between the internal walls on the top and those on the ground floor.
There are interior walls that have a sole plate. In this case, we don't have a sole plate, we just have a latch on the wall. Then the wall slips along the latch, is fixed and placed on the floor.
The team installs 13 interior wall components within 4.5 hours. Now, the installation team can get to work on the roof. The small roof trusses for the dormers have been assembled in Sweden and transported to Germany. The team cannot assemble the large rafters for the main roof until it's on site.
They are too big. You can't transport these fully assembled. They're too big for that.
The carpenters fit 30 rafters to the roof trusses using a pry bar. In the factory, there's a machine that will do this automatically. On the construction site, this all has to be done by hand.
Now we attach the first roof truss to the gable wall in the lower part. These will simply be nailed and later we add brackets.
The team first secures the roof trusses with brackets. Then they're connected by horizontal purlins. In less than 4 hours, the house has a finished roof. And so ends the second day of the build. The third day of the build has begun. Assembly supervisor Detlef Buchwiese and his team work on the roof frame.
This is a subroof to which the lower tensioning strap will later be added. Counterbattens and roof battens come at the very end. At some point, the roof tiles go on. This is the subroof. These are those that we nail to the roof frame. It's important for us to work fairly quickly because then the house is protected from the rain.
The subroof is made out of a roof boarding with roofing felt or coated fleece on top. Counterbattens and the roof tiles on top come next. The subroof construction is designed to drain water and dirt away. The construction team mounts the roof panels onto the trusses. These are secured with brackets above and below the truss. Crossed metal struts stabilize the construction. The team has used 141 roof panels for the entire roof. Even the bay, whose roof will serve as a balcony for the living space on the upper floor, is sealed with tongue and groove boards.
Wir bauen hier bei dem Erker.
We add a subroof to the bay on which the balcony will later rest. Once that's finished, we make it watertight.
Und wenn das soweit ist, dann dichten wir das ab, dass es auch regendicht ist. Und
A temporary layer of roofing felt follows the roof boards to protect the interior against moisture until the balcony has received proper flooring. The third day of the build draws to a close. Tomorrow, the shell of the house has to be finished. Day 4 of the build. The main roof gets a membrane underlay made from a specially coated polyester fleece. This serves to drain away any snow or rain beneath the covering.
ja, wir bauen jetzt die
We're now building the underlay on top of counterbattens, and from time to time, we add a running batten so that we can climb up there.
Die Folie selbst.
You're not supposed to step on the foil itself without an attachment because it may tear off or you'll slip off.
Ja, und wenn wir dann
Once we reach the top from both sides, it's watertight and nothing will happen anymore.
dann passiert nichts mehr.
The team secures the counterbattens with nails. They use a foam nail seal that is applied to the battens before nailing to prevent any moisture getting through the holes in the membrane. After 4.5 hours, the battens are laid, and day 4 of the build has come to an end. It's done. The shell has been completed on time as planned. In 4 days, the construction team has installed 25 exterior components and 28 interior wall components, laid 11 ceiling cassettes, and built an entire roof. In the following weeks, the roof is covered, work begins on the interior, and the cladding is painted in its classic Swedish red color. It has been 7 months since the customers commissioned the build, and now they can move in. This Swedish house costs around 2,000 euros per square meter, including installation. So 352,000 euros in total. Life with that Swedish feeling. The number of German customers who yearn for this is on the rise. The house's traditional wooden cladding needs to be painted every 10 years. For this reason, they are somewhat higher maintenance than solid houses. Otherwise, they're in no way inferior to them.